work with our app. The first thing to do is come to our app and press the Resources tab, and notice how we've got 3 dynos, and uwsgi, uwsgi.ini is running here, as is in our proc file. The thing we care about in this video, however, is the add-ons. So we're going to click on Find More Add-ons, and that is going to bring us here to the different add-ons that we can add in our application. There is actually a lot of them, and most of them have a free tier. So we can use any of these add-ons, including data stores, but also a lot more, and often they are free. The one we're going to be using is MongoLab. MongoLab is simply a fully managed MongoDB as a service add-on. So that hosts a MongoDB database for us in the cloud, somewhere on the internet, and our Heroku app can access that. So let's log in to install here, and that'll ask Heroku for our account, and that's it. Install it and select the appropriate app, and then press Submit. Once that's done, that's it. So now we have to select which MongoLab we want to use, and I'm going to be using the free one for this instance. When your app grows, you may have to start paying if your app does make some money. And in this instance, it seems like they want our credit card to be able to install the add-on, even though it is free. So we're going to have to provide that and then come back and install this again. So in order to verify your account, you'll need to provide the credit card, as I mentioned, but they won't charge you if you're using the sandbox plan. So let's do that. And in order to do that, we'll have to, as I said, go into our account here, manage your account, and go into billing and put your credit card in here. So I appreciate not everyone likes to do this, but unfortunately it is required for MongoLab. So let's do that, and once you've done that, go back and try to install MongoLab again. Once that's done, and I'll see you in the next video, we can continue with setting up the Python app to use that MongoLab instance as opposed to the local MongoDB instance. Hi and welcome back. Once you've added your credit card to Heroku, which is unfortunately a requirement these days, it didn't used to be before, but now they require that. Remember, you won't be charged as long as you stay in the free tier for dynos and in the free sandbox tier for MongoLab. You can go into the add-on and press MongoLab, and that'll take you to the MongoLab, essentially, page. And here we can see, the MongoLab page, and we've got the essentially the MongoDB URI that we have to use. This used to be 127.0.0.1:27017, and now we have to use this other one, which is right here. However, we also need to define a database user and password. So the way we're going to do that is go into a Users tab and click Add Database User. Here you can select your database username. I'm going to select something like School of Code and put in a password. Make sure to put in a safe password, something long and secure so other people cannot access your MongoLab account. And in my case, I'm just going to generate one that is very long, and then do not check make read only and press create. So let's do that, and I'll see you in just a moment. Once that's done, you'll have your user here at the bottom, and we can go and view stats, what's happened in our database, and also the collections that we've got in it. And at this point in time, we don't have any because we haven't yet used the app. So now that you've got your username and password, we are simply going to copy that, and then in the next video, we're going to be adding that into our app. So I'll see you there. Hi and welcome back, and in this video, we're going to be adding our MongoLab URI here in our application. So what we want to do can be one of two things. Open up the common database.py and instead of the URI here, just paste the one that we've copied. However, evidently there is a problem, which is that we have to include the user and password of the database here in the code, which we're then going to put in GitHub, which means it's going to be viewable for other people to see. Not very safe. So what to do instead of that is select this and type os.environ.get and here MongoLab URI and then import OS. Fantastic. So now that's set up, and actually MongoLab adds this environment variable for you already, so you don't really have to do anything else. The user that we created in MongoLab, we can use that if you prefer, in which case we'll have to go and change the environment variable that we've got here. But if you just leave it as it is, it will use the default user for MongoLab, and that should work. So what to do now is just commit and push this and then deploy again and see what happens. So let's do that. What I'm going to do is open up the terminal and now type git status, type git commit am, adding the ability to read environment variable in database. And now git push. And that now goes over to the GitHub repo, the remote repository, and we can finally go over to our app, press deploy, and type and press deploy branch here. Once that's deployed, then we can go and verify that our app is working. Okay, so that's now deployed. Let's press view and see what happens. And we get another internal server error. So we're going to have to fix this before we can continue with our app. One essential tool of Heroku is the ability to view what happened during the deployment and during the running of our application. And that's going to give us some insight as to why our app failed. The way to do that is type Heroku logs --app and then the app's name. And now this is going to tell us essentially everything that happened towards the end. So the last log that we received is no Python application found, check your startup logs for errors. Okay, so what this is basically saying is there is no app running, so when we ask the app to load, it can't do anything because there's nothing there. So therefore, what that tells us is that our Python app must have failed to start up. So if we go up here, we can start seeing some things. Let's go up to the very top of this here. And what it's doing is it is exited the process with a status 0, and then it's giving us the error log. Status 0 means it didn't quite work, and then it gives us the errors. The first error says import error. Module src, our src folder, has no attribute config. There is no config file inside our src folder. And indeed what happens when you go into the GitHub repository is that the config.py file is not in that repo. So what we have to do is make sure to add that file into the GitHub repository and then push again. The reason why the config file is not in the repo is so that people didn't see your email, and indeed so that when you forked the repository, my email wasn't there in your app. So what we have to do is make sure to undo that, the fact that I removed the config file from the repo and add it again. So what to do is say git add src.config.py. And it says the following paths are ignored by one of your .gitignore files. So the .gitignore file gives us some files that we want to ignore. If we open up the .gitignore file, you can see that indeed config.py is one of the files that we are ignoring. Press the key D twice to delete that line, and then press :WQ. Now we can rerun the git add command, and now git status tells us that we've added this and we've created a new file. So let's commit am added config file with the email. Remember that you may have this as an environment variable, and that's absolutely fine as well. And then git push. Once that's pushed, we can once again go into our Heroku app, deploy it again, and see if everything is working. So I'll see you in the next video. Hi and welcome back. Now that we fixed that bug by looking at the Heroku logs, we are ready to try out our application. Remember, automatic deploys from master are enabled, so if you've waited a couple of minutes, then your commit will now be live in your application, and you just have to go and view your app. However, if you want to deploy the thing immediately, you can always deploy the branch manually. Okay, so let's have a look at the app and see if it's working, and if not, we'll have to go back and look at the logs again. But it seems like it is working. Here the URL is showing as the correct URL, and the homepage looks like it is working. If we go on the stores, we seem to get an internal server error, which is not ideal. If we press the sign up page, that seems to work. If we press the login page, that seems to work as well. So what to do now is go onto the stores and then look at the logs, and the logs may tell us what is wrong. So I'm going to do just that. I'm going to check the Heroku logs app pricing service School of Code. And because I check the logs last, then here there will be something to tell me what happened in that request. As you can see, this request here says method get path stores host pricing service school of code.herokuapp.com, which is my URL, and the stores path is the store index, which just gave us an error. And as you can see, the status is 500. 500 as a status means that something went wrong. It is the code for an internal server error. So we need to figure out exactly what happened, what could have caused this error here. So in the next video, we're going to go over our Python application and see if we can find out the source of this error. I'll see you there. Hi and welcome back. In this video, we're going to be fixing the error that we got in the last video. And that is actually a very difficult error to track unless you've got a bit of experience using MongoDB. Now, the problem stems from a limitation here in MongoLab, which is the free version of MongoLab that we're using. It has a small limitation, which is that they give us a database and we can only use that database. So let me explain a bit more what that means. In order to understand where this error comes from, we need to understand the structure of this MongoDB URI. A MongoDB URI is oftentimes in this format, where you've got MongoDB : //, then you've got the database user, which MongoLab gives us, then you've got a colon, and then database password, the password associated with that user, that MongoLab also gives us, and then you've got @ and then ds00 blah blah blah, which is the address of the MongoLab server in which our database lives, and then we've got a port, which is what we use to connect to that database, and finally we've got something at the end there that looks very much like our user account and is in fact the same. Now what that is something very important, which is the database that MongoLab gives us to work with. We cannot create other databases in MongoLab for security purposes, and also because of a limitation in the free tier. I'm not sure if this limitation does not exist in a paying tier, but certainly in this one, there seems to be no way to use a different database. Now, if we go to our code, into the database method, we are getting the MongoLab URI from the environment variables, which is fantastic. And then we are creating the Mongo client using that URI. And finally, here's the problem. We are selecting as a database the full stack database. Now, we do not have a database called full stack, and we cannot create it because of that limitation. The database we have to use is in fact this Heroku_15C13VNT, which will be different for your account, but this is the one I'm allowed to use. And that is here at the end of the MongoLab URI. And in fact, it's going to be quite handy that it's there at the end of the MongoLab URI, because there is a special way to access a database that is here at the end of the URI. And the way we do that is we say client, instead of full stack, we say client.getDefaultDatabase. Now the default database is the one that is at the end of the URI. So if we do this, and then we commit and push the changes as we know, then everything will work. So let's do just that, and then I'll see you in the next video where we'll verify that everything is working and whether we've got any more problems that we have to fix. I'll see you there. Hi and welcome back. Now that we've used the default database from the URI and we've deployed to Heroku again, or you've just pushed and Heroku has done all the work for you, we can go and see if the stores are working. And it seems like the connection to the database now works, and that seems all fine. Let's go to the sign up page then and sign up. And I'm going to sign up with my personal email, which is the administrator's email. So I'm just going to use any password there. And then we seem to have logged in. We can view the stores, and because I'm the administrator, we can now create new stores as well. So it seems to be working, and now we are essentially ready to give this link out to our users if we want to stick with Heroku, or now that we know this all works, we can start using a different server for deployment to our users. Remember, Heroku in its free tier is not very powerful. They give you one server and they turn it off whenever somebody's not using it. So if we don't use the app for a while and then we press refresh, it actually takes like 10 seconds to start up because the server is waking up. So that's not ideal. It's better if we, instead of using Heroku for our deployments to the end users, we use something like a DigitalOcean server. Those servers, although they may be slightly more expensive, although I'm not entirely sure that is true, they don't go to sleep. You are not limited in the amount you can use. You've got that server and you can use that server to its fullest. Now, the cheapest servers in DigitalOcean are not very powerful either, but they are plenty powerful for what we're doing here, and they are very cheap. So in this section, we've learned how to deploy to Heroku, and this is fantastic if you're doing something really quick. You just set it up, and then every time you push to GitHub, it just gets deployed, and then you can test it and verify that everything's working. Deploying to a server in DigitalOcean may be a bit more work, but it will work better once it is everything's set up. When your application is working and you want to deploy it to your end users for them to use, I would recommend using something like DigitalOcean, or even better, setting up a server in a different provider. And we'll get into why I said even better in that phrase in the next section. DigitalOcean is a great service, but the servers are not the most powerful. There are other options out there which are more expensive, more powerful. Depending on your use case and how much people are going to use your app, you will be picking one server over another. But what we'll be learning in the next section, which is deployments to DigitalOcean, we'll actually be deploying to a Linux server, and whenever you deploy your app anywhere in the world, even if it's not with DigitalOcean, you will be using a Linux server 99% of the time. So what we're going to be learning in the next section is actually going to be extremely useful for you. Okay, so with that said, this is now working feel free to go to the URL pricing-service-schoolofcode.herokuapp.com and try it out. Or hopefully by the time that we're here, you will have managed to deploy your own instance, and then you can see that it all works. You can make changes if you want, and that's your own app that is now live on the internet. So let's move on to the next section, where we're going to be learning a lot more about Linux and deploying to a Linux server. I'll see you there. Hi and welcome back. In this section, we're going to be looking at setting up and deploying our pricing service app to DigitalOcean. We've looked at deploying to Heroku, and Heroku is fantastic because of the way that it is set up, and also the fact that it's free for small applications. And now that's great because as you're developing your app, you normally would want to test it online to see if it works in the same way as in your computer. However, once your app is ready and it is finished, or at least you want to start sharing it with people, Heroku in the free tier is not ideal. And it's not ideal because in the free tier, Heroku apps go to sleep every now and then, so they become unavailable. And when that happens, you have two options. Either you start paying for Heroku, which can be a bit expensive, but you have that ease of use, which is nice, or you set up your own server using something like DigitalOcean, OVH, and there's a number of other providers. I'm going to teach you guys how to do the deployments with DigitalOcean simply because it's really simple. It's really easy to get a server. It's really quick, so you guys don't have to wait. And also, I'll provide you guys a link that gives you 2 months for free, and that's a referral link, so I also get some benefit from that as well, so you guys can use that if you want, or not use it if you don't want. And that's in the lecture description. The first thing to do is go to digitalocean.com and register an account, and then you'll get a screen like this one here, and I've got my 2 droplets, and droplets are just servers. And I've got 2 here. I know they're blurred out because of the details that I don't want to put in the video, but nevertheless, you'll see something like this, and then you can go and create your own droplet. Creating a droplet with DigitalOcean is really simple, and the only thing you have to do is select a few options, and then it just gets created for you. It takes just a couple of minutes. The first thing we have to know about are the Linux distributions. Now, well, actually before that, we need to know what Linux is. But Linux is just operating system like Windows or like Mac. And Linux is free in terms of you don't have to pay for it. And some of these are slightly better than others for what we're trying to do. Ubuntu is a very popular Linux distribution, especially used when you want to install it in your computer, but it's also highly used in servers like the one we're wanting to set up here. And Ubuntu is great for those reasons. However, it doesn't have as much long-term support, I'd say, as other distributions. These two, CentOS and Debian, are slightly more stable, and they're more used in the professional world. FreeBSD, Fedora, and CoreOS I've never encountered professionally, and I wouldn't suggest you use them unless you know what you're doing. The choice comes down to Ubuntu, Debian, or CentOS, and I would recommend CentOS because it is the most stable of the 3. You are not going to see many changes in CentOS at all, and version 6.7 is the most stable version of CentOS, but you can also use 7.2 if you want. There's only a couple of minor changes there. I would recommend using 6.7. That's been around for a long time. And naturally use 64-bit rather than 32 bits, just because there's a lot of things that no longer work with 32 bits. 64-bit is the new, not really that new, but it's kind of what you should be using nowadays. So let's pick 6.7 CentOS in 64 bits, and then we get to choose his size. Because we're only learning here and we are not really deploying an app to be used by a lot of users, I would recommend just going for the cheapest option, which is $5 a month which is quite cheap. And if you signed up with the link that I provided, you've got 2 months of this for free, which should be enough for you to learn how to do this and try it out. Do notice that it is billed per hour. So if you just want to try this, create a droplet, do the deployments, learn how to do them, and then destroy the droplet, you'll maybe spend around 10 cents, which is not a lot, or less. Okay, so once you've chosen your size, we can come down here and choose a data center region. This is necessary because of the way the internet works, essentially. If you are in the US, you may want to choose New York, San Francisco, or potentially in Toronto, depending on how far up north you are. And that's just because your connection to the server is going to be slightly quicker. And if you're not going to be sharing this app with a lot of users, what you want is the quickest connection for yourself. If you're going to use this app with a lot of users, then what you want is to choose the data center that is closest to most your users. The Amsterdam data center is particularly fast, so I'm going to go with that one. The London data center sometimes has a few problems. I'm not sure why. Singapore is too far away for me. I'm in the UK, and Frankfurt is reasonably close, and the US and Toronto ones are too far away. So if they are too far away, you're just going to see a bit more latency in your connections and your commands when you execute them on the server. Although they're going to run at the same speed once they're running in the server, they're just going to take a wee bit longer to get to the server. So for example, when you install your application, you'll tell the server, please install this, and then telling the server will take maybe half a second, and the server will then run it at normal speed. Whereas if I choose Amsterdam, telling the server may take 100 milliseconds, and then it will start it. So it's not a lot of time saving. It's maybe 400 milliseconds. But nevertheless, I'll go for that. Finally, you can select additional options, such as private networking, which allows your droplets to connect to one another without going over the internet. And we don't need that in this deployment. You can choose backups, which increases your monthly cost by 20%. So it goes from $5 to $6. And that's really good. I would recommend doing that if you're going to be deploying the app and using it with a number of users, and you're actually interested in keeping the app running. You can choose IPv6, and that's sometimes necessary because there's just not that many IPv4 addresses left. The IPv4 addresses are just the numbers like 123.8 something else. That's an IPv4 address, and IPv6 addresses are a lot longer. Which means there's more of them. Each server gets assigned a unique IP address. IPv4 addresses, there's fewer of them, so potentially your server will struggle getting one. IPv6 is better for that reason. And user data, I'm not really sure what that is. I wouldn't use it. I've never had the need for that. Finally, you can add your SSH keys. Now, SSH keys are a way of logging into your server without needing a password. An SSH key is unique to the computer in which you generate the key. So if you generate an SSH key from your desktop, then that desktop can log into the server without using a password. However, if you then get a laptop and try to log in, then you'll need a password. So SSH keys are only for single computers, and in this case, I'm not going to implement an SSH key login, but you can do so if you want, and DigitalOcean has guides on how you can create SSH keys. Finally, you can choose many droplets if you want more, and you can give them a name for you to remember the name easier. Instead of CentOS 512 megabyte Amsterdam 2-01, I'm going to call this pricing-service. And that just helps me remember it. And I only need one droplet, so that's everything we need. And now that's us set up. We're going to press create, and do notice that's going to start charging you, and you're going to get your droplet in around a minute. So now that's creating the droplet here, and notice how that progress bar goes quite quickly. And up here it tells you the sort of specs of your new server. It's important to note that this server is just like a computer. So essentially, it's a computer running somewhere in DigitalOcean's infrastructure, but it is a computer just like your desktop or just like your laptop. So when you log into it, you're going to have access to the normal programs that a computer would have, although we're going to be accessing the servers only via the text console, the terminal. So you're not going to have access to a desktop, just the terminal. And also, naturally, the operating system that's running in this server is CentOS 6.7, so it's not going to be identical to any of your operating systems unless you've used CentOS in your desktop or your laptop. With that said, we're ready to move on to the next video where we're going to be setting this up and creating accounts and logging in. So I'll see you in the next video. Hi and welcome back. In this video, we're going to be setting up the server that we've just created. Two things that you're going to need is the IP address of your server, which is here, and also you should have gotten an email with the password for the login. So that's the root password. So get that password and then get the IP address, and let's go over to a terminal and we can start the login process. If you are using Windows, you may have some difficulty executing this first command. And that's because Windows doesn't natively support the command. If that is the case, you're going to need to download a piece of software called PuTTY, and I'm going to link that in the description of the lecture. Once that's done, the only thing we have to do is do SSH, and then root at, and then your IP address. So let's get that IP address. It's 82.196.4.5. Okay. Then press enter, and then this will ask me. The first time you connect to it, it may ask you to verify that this server is the one that you want to connect to, and in this case, yes it is, so just say yes. And then it asks you for the password, and this is the password that was in your email, and normally you can paste it in. So I'm just going to paste it in. And then it asks me to change the password immediately. And that's a good recommendation. So just paste it in again, and then select a new password. Notice how you can't see me typing there, but nevertheless, I've set a new password, and then you should do the same. Once that's done, you have logged in to your server. Notice how the server name is pricing service, and you are logged in as root. Root is a special user that has absolute power. Think of it as an administrator in Windows, and you can do anything you want as long as you're logged in with the root user. If you're logged in as a different user, then there's things that you may not have access to, and if you're logged in as a different user, you won't be able to interact with files and folders created by somebody else. And that makes sense. You don't want other people deleting your stuff. The next thing is this small tilde. And the tilde is the current path that we are in. So notice this is a computer, and just like your computer, it's got folders and it's got files, and you can have folders inside of folders, just like in your computer. And the tilde is just a special folder. And the way we can find out what path the tilde is by typing pwd. And that gives us the presently working directory, and that's the current directory we're in. And that gives us the present directory, which is /root. The slash directory is the topmost directory of your server. So basically, that topmost directory has all the other folders that are in your system, but those folders may have other folders inside it. We can change directories by doing cd. CD stands for change directory, and we can go, for example, to the root directory, the topmost directory in your computer. And when we do that, notice how the tilde changes to the path that we're in. The tilde is only present when we are in the current user's home directory, essentially the user's folder, if you wish. If we go into a different folder, it'll never be the tilde unless the folder we're in is the user's home directory. I know this is a lot of info to take in one video, but these are just Linux tidbits that you should know, but they're not going to affect your ability to make a deployment. The first thing we have to do is to set up a user that is not root so that we can log in as that user. And you may ask, why? Let's just use root since it has access to everything. And the reason why we don't want to use root is precisely because it has access to everything. It's really easy to make a mistake that then you cannot undo. For example, a mistake that you could do, that you shouldn't do, and don't do this, is rm-rf, like so. If you execute this command as a user that is not root, you'll have some problems, but it won't be too bad. If you execute this command as root, you'll have to purchase another droplet and reinstall CentOS, etc. And that's because rm stands for remove, -r stands for recursive, f stands for force, and this is the root folder, and the asterisk stands for everything. So basically you are recursively removing everything in the root folder and forcing the removal essentially. So basically this is going to delete everything in your system. Don't do that. Don't do that command. You'll just have to reinstall. The first thing to do is to add a new user so that we don't have to use the root user. And the way we do that is we're going to execute a program called add user. And the program is inside the usr folder /usr /sbin/add user. And that's the program we want to execute. And that program also takes in a parameter, which is the name of the user we want to add. So in this case, I'm going to call it my name. And that's that done. We've now added the user called Jose. And the next thing we can do is change the password, or basically give it a password. So I'm going to execute the passwd command that changes the password of a user. And once again, I have to give it the user that I want to change the password of. And then it asks me for a new password, so I'm going to put that in. Oops. There we go. And now that's that done. So now I've created a user and given it a password. Notice that in the first instance, we specified the full path to the program. This program was in /usr /sbin/add user. But we didn't do that for the passwd program. And that's just so I could show you that there's two ways of executing programs. Let's execute another program that I'm going to use in the explanation. And the program is echo. Echo just prints something out to the terminal. So I'm going to echo $path. And the path variable is a special type of variable. Whenever you execute a program such as passwd, it's going to see if that program exists in any of these folders. And note how they're delineated by a colon. So it's going to look for passwd inside user local sbin, then it's going to look for passwd in user local bin, and then in sbin, and then in bin, and then in user sbin, and then in user bin, and then in root bin. So it's going to look for that program in any of those, and when it finds it in one, it'll execute that program. Notice that you may have programs in multiple places that do different things but are called the same, so this is maybe not ideal. If you specify the full path, then you know which program you're executing. To make sure that the passwd is the right program, we can do which passwd, and that tells us where it is, and it is in user bin passwd. So that's the program we executed up here. We've looked at a bit of Linux, how to interact with the console, and getting the current directory, changing the directory, executing programs in two different ways, including adding a user and changing the password. And we've looked at echo and which, and one of them prints things out, and the other one tells us where the program lives. So this is a lot to take in for one video, so let's stop here, and then in the next video we're going to be allowing us to log in to the server as the new user we've added. Because right now, this user does not have privileges to log in via SSH, which is how we've logged in as root. So let's do that in the next video, and I'll see you there. Hi and welcome back. In this video, we're going to continue with the deployment, and setting up permissions for our new account. I've opened here a new terminal, and if we try to log into our server using the account we just created, which would be SSH, the name of your account, which in my case was my name, and then your IP address. If you try to do that, I'll get that, but you won't get that. And then you'll get asked for a password, and then you can log in there. Now, there is a couple of things that we have to do to be able to complete the setup. One of the things we have to do is give this account administrator permissions, essentially. And what that means in Linux terms is allow this account to use the root permissions, the permissions of the root account, to perform some commands. For example, if we wanted to start up a program when the server reboots, we would need administrator commands to do that. If we wanted to install a program globally, not only for the current user, Jose, but for all users, we would also need administrator commands for that. And there are a number of things that we need root permissions for. So it's important that our account has that, because we're going to be installing things and stuff like that in this server. We're going to be installing programs that our app needs. So we need administrator permissions. We need to be able to use the root permissions in this account. And in Linux terms, being able to use the root permissions means being able to use a special command called sudo. And from now on, that'll be sudo permissions. Now, what I mean with this is we will be able to do sudo and then do a command. For example, if right now we try to do add user, we get permission denied, because add user, the act of creating a new user in the system, is only allowed by the super user, the root user. So we would have to do sudo add user. But when we do this, then we'll get asked our password, and we will get this message here, that this account is not in the sudoers file, and this incident will be reported. That's just to scare you, really. So what we have to do, naturally, is put this account in the sudoers file. And to do that, naturally, we need to be able to use the root permissions, which means we cannot do this from this account. We need to log out, log in back in as root, and then we can do that. So let's do that. You can always log out of an account using Control-D. I'm going to press Control-D, and then that logs you out of this account. And then we can do SSH root at the IP address, and we can put in the password for root this time around. And then we are now logged in. So, what we want to do now is go and modify this sudoers file that we saw above and add in the account that we created and that we want to add to be able to have root permissions. And the way we do that is with a command called vsudo. Notice how in order to do this, we need root permissions, but we are the root account, so we don't need sudo. If we were not the root account, we would need to run this command with sudo, but because we are the root account, that's implied, so we don't need that. So the only thing we have to do is run vsudo or vsudo, and then we get this massive file, which you can navigate with your cursor, with your arrow keys. You can go down and see what's in here, and a lot of these things are comments. The things that have a hash symbol in front, they're just comments. And notice that lines can sometimes span multiple lines here, but there's still one line. If I go down, then that skips the remainder of the line, so that's all one line. So it's all a comment. And this is reasonably big. So what we want to do is find a section that matches a specific structure. So the way I'm going to do that is I'm going to type question mark, and notice how it appears down there. And then I'm going to type all equals, open bracket, all. And then that finds one instance of that, This is not the instance I want. So I'm just going to type in another question mark and press enter again, and then that's going to just redo the search again, and it finds the next instance, which is here, and then I'm going to type the question mark again, and it finds the instance that I actually want, which is this one here. As you can see, this comment here says, next comes the main part. Which users can run what software on which machines, aka the sudoers file. So what I'm going to do is just go to the end of the file and then press the letter I for insert. And now you can just type in as if this were a normal text editor. And I'm going to put in Jose, press tab, and then all equals all, and then press tab, and then all again. And that just mimics exactly what was above, but instead of with root, with the name of the account that we've created, and this is going to give that account permissions to run sudo and run root commands essentially. And then what we'll do is, because we're in insert command, in insert mode down here, you can see that, we're going to press escape, and that's going to get us out of insert mode, and then we're going to press :W, and that stands for write, or aka save, and quit. So that's going to save the file to the disk, write it to the disk, and that's going to then quit. So when we do that, it just works. And now we could log out, log back in as the other account, and then we could use the sudo command normally. However, we are going to make a couple more changes. And the first change we're going to make is to prevent people from accessing the server from logging in as root. We don't want people logging in as root, because if somebody finds out our root password and logs in as root, they've got access to do anything they want with our server. So we want to prevent root access to the server. That's just a security measure. And the way we're going to do that is by using the vi command. That's just a text editor, just like we did up here. And vi sudo is a special command that runs the vi editor to modify the sudoers file. And now we're going to run the vi command to modify a different file. And the file we're going to be modifying is the SSH configuration file. And that file is in etc/ssh/sshd config. So you just type that, vi, and then the path of the file that we want to modify. And in this case, the file is in /etc/ssh/sshd config, and then press enter, and you'll once again receive the vi editor. And once again, most of these things are comments, but at some point down below, we're going to search for it again, pressing the question mark. There's going to be a line saying permit root login. So just search for that and type that again, and here we go. This is the line we want. Permit root login, yes, but it is commented out. So what we're going to do is press the X key, and that's going to delete. And then we're going to go to the end of the line and press X 3 times. And then go to insert mode by pressing I and typing in no. And that's just going to make sure that nobody can log into the server directly as root. Okay. And now what we're going to do is press escape to leave insert mode. And then we're going to navigate to the end of the file. Now there's 2 ways you can go to the end of the file. Just use the arrow keys until you reach the end, or you can press Shift G, and that just takes you to the end. Okay, and then we're going to add a new line down here. So go back into insert mode by pressing I, and then say allow users, and then the name of the account that you created. And that's just going to give us access to log in and basically do everything we want, just to make sure that everything's working. And as you saw, I could log in as this account before, but in some systems it may not be allowed from the get-go. So this is required as well. Okay, and then :WQ again for write and quit. Remember to leave insert mode before doing that. And finally, the last thing we want to do is do service SSHD reload. And what that does is it reloads the SSH service. And if you're wondering what the D stands for, is the daemon. And what a daemon is essentially just a process that's constantly running in the background. So it's reloading the service that allows us to log in to the server from our computers. So just do that, and then that reloads it, and now we're done. So basically now, all we have to do is log out, and you guys know how to do that. Just press Control-D, and then you can log in as the account that we used before. It'll ask you for your password, and it should all work. And now if we do something like sudo sudo, for example, it should ask us for our password and let us run it, which it does. Whereas before, it would have said that we're not in the sudoers file. Notice how I quit that file just by pressing :Q from vi. Okay, so this is the setup that we needed, and now our account on our server is safe. We cannot log in as root. You can try that if you want, but we cannot log in as root, which gives us just a slightly better security, and our account is allowed to use sudo, which means that it's got access to do pretty much anything. But naturally, you need to know that account's password as well. Now, what I'm hoping is that the password you've chosen for your account is very safe, very secure, or that you're using an SSH key, which we're going to look at later on, to maximize the security of your server. So we're going to be looking into that later, so don't worry much about that. Just make sure that your password is reasonably strong. And now we're ready to move on into the next video, where we're going to start the deployment of the app itself. So I'll see you there. Hi and welcome back. In this video, we're going to be deploying our app to the server. Now, this is a multi-step process. It's going to take a couple of videos, but just follow along, and I'll be explaining what I'm doing as we go along. The first thing we have to do, naturally, is log into our server. So I'm going to do that. And then it'll ask you for a password. And remember, you cannot log in as root, and you shouldn't log in as root whenever possible. You should try to avoid that, simply because it gives you too much power, and it's easy to mess things up. That's one of the main reasons. Now, the first thing we have to do is install, naturally, Python. CentOS comes with Python. If I run the Python command, I get the IDLE, the console. But if I do Python -- version, notice that it's Python 2.6.6. So what I'm going to do is I'm going to install Python 3.5. You can run this with Python 2.7, that's totally fine, but Python 2.6 is just a tad older, so I would recommend either Python 2.7 or Python 3.5. In this video, we're going to be going over installing Python 3.5 just because it's newer, it works, so might as well go with that. Before we can install Python, we also need to look at how we install things in CentOS, or indeed pretty much any Linux distribution, and that's using a thing called package managers. Most programs are available through package managers, but some will not be available, just because there is a process that the program creator needs to go through to put their program in the package manager, and some people don't do that, or you know, a variety of reasons. A package manager is just a tool, it's just a program that lets you install other programs easily. In the case of CentOS, the package manager that is available in CentOS is called yum. In Ubuntu, the package manager is called apt. And then you can use apt to get software and install it in Ubuntu. In CentOS, we use yum, and there's a couple others as well. But the only thing we're concerned with in this video and in this operating system is yum. As I mentioned before, to install things, you need to be able to use an administrator account, or you need sudo permissions, essentially. Now that we've got sudo in this account, we can install things directly from here. Do remember that running things using the sudo command, sudo and then something, is as if you were logged in as the root account. So basically, this gives you absolute power to do anything, and therefore you should use it with care. Only use the sudo command when required. Don't just use sudo for everything. And then the first thing we want to install is sudo yum group install and then development tools. And what this does is it installs a group of programs defined by this name. And this name is the name of the group, and it's going to install every program inside that group. And these development tools group just installs up a bunch of things required, like C compilers and things like that. Essentially things you need to be able to then compile Python and install it. So let's press enter. And notice how it asks me for my password because I'm running things as sudo. And then it starts kind of doing its thing and installing things that it needs. And it's going to install quite a lot of stuff. So I'm going to speed up through this part of the video. Remember to press the Y key for yes once it tells you what it's going to install, and it also tells you how much space that's going to take. And it's going to install 112 packages. So press Y, and I'm going to speed through this part of the video. Okay, now that's installed, and it's installed a bunch of things, and you can have a wee look at some of the packages that it's installed. For example, an important one is this one, the standard library of C++ used for development mode. It's installed a bunch of things to do with Perl, which is a useful language. It's installed rsync, which is used also quite a lot in Linux for synchronizing folders across systems and things like that. It's installed glibc, which is very useful. Free type for different types of fonts. I saw something related to Git before earlier. I'm not sure where it went. But nevertheless, it's installed a bunch of things. And they're all kind of required for what we're doing here. And the next thing we want to install is also a bunch of other development programs, development tools that we're going to need as well. So let's go through them all. And do notice, sudo yum install. Do notice that all of these commands are going to be available in the lecture description or the lecture contents beside. So don't worry about kind of copying these character by character. You can just copy them from there. Sudo yum install, and then we're going to install a bunch of things. So zlib.devel, bzip2-devel, openssl devel, ncurses devel, SQLite, readline, tk, gdbm, db4, libpcap, and xz. Let me just verify that I got those right. zlib, bzip2, openssl, ncurses, SQLite, readline, tk, gdbm, db4, libpcap, and xz. And everything seems right. And these are just other tools required for Python as well. For example, SQLite is very useful to be able to create small SQL databases. OpenSSL is useful for security. And there's a bunch of other things there. I don't really know what all of them are, but I know that you need them, or else it doesn't work. So there you go. And once again, press yes. And this one goes a bit faster. Okay, so that's it installed. And we've installed now everything that we need to install Python. The next thing we need is the ability to download things from the internet directly onto this server. And there is a specific program that we can use to download things from the internet called wget. And wget currently is not found, so we need to install it. And once again, sudo yum install wget. And that just installs wget. And notice how useful yum is. It just has a lot of the things that we need. And we just tell it to install things, and then it installs them, and now we can wget. And now actually works, but we need to tell it what we want to get naturally, missing URL, and we're going to do that in a moment. And now we are ready to install Python. Download Python first of all, and then install it. The first thing I'm going to do is make a directory called downloads and go into that directory, and I'm going to put my downloads in here. The Python download isn't useful after we've installed Python, so that's why I'm putting it in this folder. It's only useful to install Python, but after we've installed it, we can delete it if we want. So I'm going to type wget and then HTTP, basically where the Python download package is. And this is in python.org/fdp/python/3.5.1/python-3.5.1.tar.xz. And notice how that downloads it. And now if I type ls for list structure, I see that Python 3.5.1 is there. But it is a .tar.xz file. This is like a zip file, essentially. It's a compressed file. So we have to uncompress it, and we can do that with the tar command. So tar xf, that x tells it to decompress, and F just stands for force. So I'm going to decompress the file, Python 3.5.1, and then you just do that, and it decompresses it. If we type ls now, we see that there is another folder in there called Python 3.5.1, but it no longer is a compressed archive. So we can cd into it. We can change the directory and go into Python 3.5.1, and now we can list the structure in here, and there's a bunch of things in here. What we're going to do now is configure the Python installation for our system specifically. And we have to do this so that Python knows what sort of things it has to install, what sort of things it has to modify in the installation, and things like that. So, and also, more importantly, where it is going to be installed. So let's do that. Sudo configure, and notice how I'm putting the full stop /configure. The full stop just means the current directory, and then configure there. So basically this file up here. And I'm putting the full stop there so that the command knows that I want to run this configure file. -- prefix is /user/local, and that's where Python is going to be installed, this Python 3.5.1. And then enable shared, and then ld flags equals -wl -rpath /user/local/lib, and then close the quotation mark. Okay, so a lot of stuff here. Remember, you can just copy this from the lecture description. I'm not going to ask you to type it all. And do that, and it's going to take a wee while as well, so I'm going to speed up through this too. Okay, that's that done. And finally, what we want to do is compile the Python sort of program and then install it. And the way we can do that is by sudo make. That is going to compile it. And after compiling it, we want to install it. And we can chain commands using bash. And the way we chain commands is with the &, sudo make alt install. So what that's going to do is run the sudo make command. And when that finishes, it's going to run sudo make alt install. So it's going to run 2 in 1. Not at the same time though, remember that. First one and then another. And the first one is going to compile it, and the second one is going to do an alt install. And it's important that you do alt install as opposed to just install. So let's press enter, and it's going to run sudo make first, and then sudo make alt install after, and that's going to essentially finish installing Python here. Okay, that's that set up, and that did take a while, so let it run, and then eventually it will finish and you'll see your command prompt again, like that. Now we're still in the Python 3.5.1 folder, so we're gonna go up back into our downloads folder, and we can do that by doing cd ... and that just goes to the parent folder. And now we're in our downloads, and we can now get the last couple of things we need for running Python. Which, by the way, we can already run, but we need just a couple more things. If you run Python 3.5, you'll notice that now this works, and we get Python 3.5.1 version. So that works. But before continuing, we need to do 2 more things. One is change permissions of folders so that our account has access to them, And the other is to install the virtual env executable, which will allow us to then create virtual envs for our project and potentially other projects. So the first thing, change permissions of folders so that our account has access to them. And there are two folders that we're going to need access to. User local bin and user local lib. And we need access to them from this account. The way we change access to folders is by using sudo chmod, and then we specify the permissions that we want to change to. So in this case, it's 777. I'm going to explain exactly what that means in a moment. And then user local bin. Okay, so what this does is it gets the user local bin folder, and with this flag here, -r, it goes recursively into the user local bin folder and gets all subfolders and all subfiles. And then it changes the permissions to 777. And what 777 permissions means is that anybody has access to read, write, and execute things inside that. I may go into more detail regarding permissions later on, but it's not really important for you to know exactly what that means just yet. It's a bit complex, but it's not really that difficult. I'll go into it at some point. So that's the first thing we want to do, and naturally put in our password, and then do the same thing, sudo chmod 777-r for user local lib. And that's that. Once you've done that, we are ready to now move on and install the virtual environment. So let's do that. Okay, so the next thing we have to do is install one last thing, which is the virtual environments. And we need to be able to create virtual environments to be able to then create one for our project and maybe others for other projects if we so desire. So pip 3.5 is what we need. Remember, if you just run pip, that'll be the default CentOS version, which is 2.6. So let's run pip 3.5 install virtual env. Oh, I misspelled that. Virtual env. There we go, and that's that installed. And now we are ready to proceed and install Nginx, which is the service that is going to be providing access to our application. So I'll see you in the next video where we're going to be doing just that. Hi and welcome back. In this video we're going to be installing Nginx in our server. Normally, when we try to access with a browser like Google Chrome, the IP address of our server, we will just not get anything back. And that's because of a couple of things. The browser is accessing a specific port called port 80, and it's trying to get some data back from that port. If the server is not configured to return data when a program tries to access it on port 80, then it just doesn't do anything. So what Nginx is going to allow us to do is link port 80, which is one of many ports, going to allow us to link port 80 to the output of our application. And when a browser accesses the IP address of our server up here, when we access that with Google Chrome, for example, in port 80, our server, more specifically Nginx, is going to execute our Python app and is going to return the contents of the app. It's slightly more complicated than that, but that's essentially the gist of it, and we'll understand more about what's happening as we work with it. So Nginx is, it's just that, is the program that sits in between the outside world and our application, and it directs traffic to the app based on the port that the browser accesses. The browser accesses port 80 by default, but it can access other ports as well. And Nginx can then see which port the browser accessed and return data based on that. So we could tell Nginx, if the port is port 80, then access this Python app. If it's port 81, access this other Python app. So it allows us to do that redirection in the server, depending on which port was accessed. And so Nginx is known as a reverse proxy because it allows to do that redirection in the server. Let's install Nginx then. the first thing we have to do is install some dependencies. So once again, sudo yum install, and it's going to be epal release. And what this does is it installs a bunch of packages from the epal repository, one of which contains stuff that we need for Nginx. So let's do that. And then it'll install. So this is quite quick. And then we simply do sudo yum install Nginx. And this gets all the Nginx dependencies and lets us install that. Here it's importing a GPG key, which is used for signing and making sure that the program we're downloading is valid. So just press yes again. Now that that's installed, we're going to tell CentOS to run Nginx when the operating system reboots. So when we restart the server, if we ever do, which you don't tend to do, but if the server goes down, for example, and then DigitalOcean restarts it, we're going to tell CentOS to restart Nginx as well. And that's just so we don't have to then log in whenever our server goes down and restart Nginx manually. So to do that, we're going to do sudo check config levels 235 Nginx on. And this is, check config is, to be honest, quite a complicated thing. And I've not used it much apart from when it's used in Nginx. I've created a couple of check config scripts, but I wouldn't recommend that you worry about what this means. Just know that it's used to start Nginx whenever something goes wrong or the server reboots. And now that we've done that, we have to modify the Nginx configuration file so that we can link it up to our application. So let's do that now. Sudo vi, and then the config file is in etc nginx conf.d default.conf. So we're going to modify this file here, and we're going to make sure that it's linking up to our app, which, by the way, our app has not yet been put into this server, but we know where we're going to put it, or at least I do, and I'm going to tell you. So we're going to be able to do this. Now, what we've got here is a long file with a bunch of stuff that we don't really need. So I'm going to just delete everything, and then I'm going to rewrite it and tell you what's going on, essentially. So I'm going to just press the key D and then Shift G. So D and then Shift G, and that just deletes everything. And then I'm going to go into insert mode. And what we're going to be doing in this video is going over what this config file means. So the first thing we're going to do is define the Nginx server. And what this does is it allows us to listen on one of the ports, such as port 80, and then do something with traffic that is incoming to that port. So what we do is server, and then opening and closing bracket, and then we tell it which port we want to listen on. So in this case, we're going to be listening on 80 because that's the default port that web browsers access. Whenever you access a website using Chrome or Firefox, what you're accessing is that website on port 80. And there are a lot of other ports that you could access, but the default is port 80, so it makes sense for us to listen on that. Okay, and then what we're going to do is set the real IP header. And what this does is it essentially gets one of the headers from the web request and puts it as the Nginx forwarded IP. And I wouldn't really worry much about what this means. Just know that it allows Nginx to know exactly who is making the request. So let's do that. Real underscore IP header. And then X forwarded full. There we go. And finally set real IP from 127.0.0.1. And what this does is it tells the Python app who the request is coming from. Real IP header is the person that made the request, and the real IP from is Nginx, because Nginx is installed in the same server as our Python application, and 127.0.0.1 is the current server. So Flask is going to know that it is Nginx, or rather another program in the same server that is making this transfer. And finally, server name is localhost. And once again, 127.0.1 and localhost are the same thing. Okay, and then what we want to do is do a location. Now what this is we could access the IP address. For example, with Chrome, you could access a website, say google.com, but you can also access google.com/something. And what this location does is it says what we're going to do when the user accesses the root of the URL on port 80. So for example, location. This is what's going to happen when the user accesses HTTP, and I totally misspelled that, accesses HTTP yoursite.com. And this / at the end is this location here. If we do something there, then this location will show that we have accessed /something. However, we can change this location down here to say something, and what that does is it would show for Flask as though we've accessed just the /. So it's useful for our Flask rules. We're going to leave it as the /, and what that would tell Flask if we access this is that the endpoint we've accessed is /something. Okay, let's just delete that. And now what we're going to do here is a few things required to pass and load data from Flask. So include UWSGI params. And UWSGI is going to be what's serving the Flask content. So Nginx is going to be accessing UWSGI, which is going to be accessing our Flask application, and then that's going to be, the Flask application is going to be giving UWSGI the content, UWSGI is going to be giving it to Nginx. So we need to include a few parameters from here that is going to allow us to get the data properly, and that's UWSGI pass, and that's var www html pricing service socket.sock. And what this is going to do is it's going to UWSGI is going to be creating this socket file, and all the data to Flask and from Flask is going to be going through this file. So what we're doing here is we're just getting the data from that socket file, which is going to be populated by Flask. And then we do UWSGI modifier 130. And to be honest, I have no idea what that means, but it nevertheless is there, and I think that's to do with how long threads live when an error does happen. So if you want to not include it and see what happens, by all means go ahead. Then error page 404 is going to be 404.html, and location equals 404.html is going to be root user share nginx html. And what that does is it just sets the error page of a 404 request to be 404.html. And basically, when we access something that doesn't exist outside this location there, it's going to tell us 404. And the same thing with the error pages for 500, 502, 503, and 504, which is 50x.html, and location equals 50x.html, root user share nginx html. There we go. And what this is doing is setting the error pages for these error codes, 500, 502, 503, and 504, to be this 50x.html page. And these are created for you. They're inside this folder. So what that does is if we do get an error, such as error 500, we're going to serve this page. And the error 500 just means internal server error, and you can Google what these other errors mean as well. Now we've done that, we have basically configured Nginx to listen on port 80, and when we access the root location of our website, we are going to communicate with UWSGI via this socket file, and UWSGI is going to be populating that with the Flask application's output, and then that's going to go back to the user with the content of the app. So basically this is just a connection to our app, but it's a necessary connection. Oh, that was tough. And now we can press escape to leave insert mode and press WQ. There you go. And now we've saved that. And the last thing we have to do is sudo vi etc nginx nginx.conf. And we have to put in the password and just go down here to worker processes and replace the 1 by 8. So you can go into insert mode and delete that and put in the 8, then press escape to leave insert mode and press :WQ. Finally, because the account that's going to be running UWSGI and Flask is the account that we're logged in as, we have to add that account to the Nginx group so that it can communicate with Nginx, and so that Nginx then has access to do everything it needs. So sudo usermod ag Jose Nginx, and what that's going to do is going to add to a group this account, and the group that we're going to add to is the Nginx group. Now, I'm not going to go into what groups are, but just know that groups have also permissions as well as user accounts. So if our account belongs to the Nginx group, then the account has access to whatever the Nginx group has access to. So just do that. And now we are essentially ready to install the app itself. So I'll be doing that in the very next video. I'll see you there. Hi and welcome back. In this video, we're going to be installing the application that we're going to be deploying. And I apologize for the length and complexity of these videos. I know that it's a bit tedious to go through all of this just to get an app deployed when deploying with Heroku was so simple, but this is so much cheaper and better once it is deployed, and you have a lot more power to do whatever you want with it. So I would really recommend sticking through, even though it is a bit boring to learn about all this stuff. So, and with that said, let's now install the application. First of all, I'm going to go into this default conf file just to show you something. So I'm going to press the up arrow, and that just cycles back through commands I've written previously. And what I wanted to show you is the location of this socket file. This is, remember, the socket file through which Nginx is going to be communicating with UWSGI, which is going to be communicating with the Flask app. And this socket file is in var www html pricing service socket.sock. This is where our app has to be in order for the socket file to appear there. So let's create this directory, the var www html pricing service, and then we'll put our app in there. So I'm going to quit this, just :Q without W because we haven't written anything, and let's create that set of directories. So we'll do sudo mkdir -p var www html pricing service. Oh, sorry, it has to be a lowercase p. That was my bad. There we go, and that creates directory var www html pricing service. So now we need to verify something. I'm going to do ls-al var www html. And this gives me a bunch of information. This is the permissions of access. This is the user that has access to it. This is the group that has access to it. This is the size in bits, and this is the date in which it was created, and this is the name. Notice how, because we used sudo, these things are all owned by root, the user root, and the group root, which means that we won't necessarily have access to it and to modify things inside that folder. So what we want to do is make sure that this pricing service folder is not owned by root, but rather by us. So the way we do that is sudo own change owner, and then Jose:Jose, and that's just your account twice. So that's your account, and that's your account's group. And then var www html pricing-service. And now, if we run the command again, notice how this is now owned by us, our account and our group. Okay. Now, the next thing we want to do is go into that folder, cd var www html pricing service, and we want to clone the Git repo where your app lives. Now, if you want to use the app that we created in the course, you're going to have to go to Git and fork the app, and then you're going to be able to install it. If you don't are using the app that we created in the course, and instead you're using your own, then you can just use the Git URL for the app that you've created. If you're using the app in the course, then you'll just have to go to the Git page, which is github.com/schoolofcode-me/priceofchair. It's not exactly this one. Just replace the colon by a slash, and you'll have to create a Git account and fork that repository, Price of Chair repository, and then you'll be able to do the clone. If you're using your own app, you can just use the URL of your app here, or rather the Git URL of your app there. Okay, so when we do this, and I'm going to put a full stop at the end as well, when we do this, this is going to fail. But that's okay, because we know why it's going to fail. So let's talk about why it's failing. Well, first of all, let's talk about what this full stop is. Git clone is going to copy the contents of this repository, essentially everything I've uploaded to the internet in Git, and it's going to put it in a folder called Price of Chair. So this would create a Price of Chair folder and put all the contents of the repo inside that folder. However, I want the contents to go inside the folder I'm currently in, pricing service, and as you know, the full stop means the current folder. So what this does is it just puts the contents of the repo inside the current folder, which is pricing service. So that's what I wanted. And the reason why it fails is permission denied public key. And what that's saying is that I don't have an SSH key for this account in this server linked to my GitHub account that has permissions to access this repository. So there's a few things that I need to do now. I have an account in GitHub, and that account has access to clone this repository, to download the repository. However, for this Jose at pricing service account to be able to clone that repo, we need to tell GitHub that this account has access to that account in GitHub. And the way we do that is with an SSH key. So we're going to generate an SSH key in this server, and then we're going to put that SSH key in GitHub, and that's going to tell GitHub that this account has access to this account in GitHub. So let's do that. The way we do that is by using the ssh-keygen command. Just do that, and enter file in which to save the key, just press enter, and then you can enter a password. Whenever you want to use the key, you're going to be asked for a password. I'm going to leave it blank just because it's a bit faster, but you should use a secure password, and then it generates the stuff here. Now that's blurred out just for my security purposes. But what you have then to do is to do cat and then .ssh idrsa.pub. And now this is going to be blurred out again, but get the output of the SSH key, copy the entire output, and then go on to the next video where we're going to be looking at how to put this in your GitHub account. So I'll see you there in just a moment. Hi and welcome back. In this video we're going to be looking at how to fork the GitHub repository and how to add the SSH key to your account. The first thing you'll want to do is, if you don't have your own app that you've created, then go to the URL provided and fork the app. So the URL provided is this one, github.com/schoolofcode-me/price-of-chair. And the only thing you have to do is fork it. You'll have to have an account for that first. Once you've forked it, you'll be received with pretty much exactly the same screen, but instead of schoolofcode-me, it'll be your username. That's your own project that you have access to, and I no longer have access to now. And then you can clone that because your account has access to it. Naturally, before you can clone it, you're going to need to add the SSH key. And also, by the way, remember, this is the URL that you're going to be needing in order to clone. So you're going to be doing git clone and then this URL here. If you forked the project, this is going to be slightly different. So remember to copy that and not use the same one as me. Go to your profile, and then you can edit your profile. Go to SSH and GPG keys, create a new SSH key, title it however you want, and then paste the content of the key in here, which I'm going to paste in, and they're going to be blurred so you can't see them. Give it a title, such as service server key, and then you can add the SSH key there. Once you've done that, everything will work in terms of cloning. So that's everything you have to do in order to add the SSH key to your account and make sure that your clone works. Remember to fork the repository and use the appropriate URL when you're doing the cloning. With that said, we are ready to move on and finalizing the installation and usage of our application in the server. So I'll see you there in a moment. Hi and welcome back. Now that we've added the SSH key for the Jose at Pricing Service account into our GitHub account, we can now do the git clone. So git clone, and then I'm going to use my GitHub repository's git URL. If you forked it, remember to use your own. Git at github.com schoolofcode-me price-of-chair.git, and remember, I want to put the contents of the repository in the current folder, so I put the full stop at the end. Remember to be separated by a space. And then it does that, and now if I press ls for list structure, I get the contents of my application in there. There's also a couple more things that we're going to be needing. The first thing is a directory where UWSGI can put log files. And the log files are going to help us identify errors, if there are any, and also they're going to give us some important information as well. So let's create a log directory. And now that's there created at the beginning. And now we also have to create the virtual environment. So let's create the virtual env, remembering to use the Python 3.5 version, and then call it venv, and that creates it in the folder. So just saying virtualenv --python equals Python 3.5, and name it venv, and now if we do ls again, we see that venv is in there. Then we want to access the virtual environment's pip, and pip, as you know, is the Python package manager, and it's going to allow us to install the packages that we specified in the requirements.txt. So let's say venv bin pip install -r requirements.txt. remember that because we want to execute a program, we have to precede the program that we want to execute with the full stop. If not, Bash will treat this as a file, and it will tell you, this is a file, what do you want to do with it? So if we do this, it tells it, okay, we want to run this file. So we want to run pip install -r requirements.txt. And the pip we are running is the pip of the virtual environment. This is no longer the system pip, which as you know was pip 3.5. It is no longer the default CentOS pip, which is pip 2.6. This is the virtual environment's pip. So anything we install now using the virtual environment pip is going to be installed only in this virtual environment, and is not going to be available in the system's Pythons. So let's do this, and that will install things, and it takes a couple of minutes. And this is what we have installed. Essentially everything that we needed there. But we also need one more package, which is uwsgi. And once again, venv bin pip install uwsgi. And that is going to allow us to run the Flask application through uwsgi. And uwsgi is then going to communicate with Nginx. Once that's installed, we have to modify the config properties of your app to make sure that you are the one that has access to everything you need. So via src/config, src/config.py, there we go. And this is a new file because it's not included in GitHub. And what we want to do is say debug equals false to make sure that our app is not running in debug mode when other people are going to be accessing it. And admins equals frozen set, and then here you can put your name at youremail.com. In my case, I would put my email, and then press escape to leave insert mode, :WQ to save it, and then via src models alerts constants.py, and make sure to put in here your mailgun details if you want to be sending emails with your alert service. So just put those details in there, and then you can once again save and quit once you've modified that. And now you are ready to run your app essentially, but there's obviously one last requirement missing, which is the database. So we need to install MongoDB, which is actually only going to take a couple of moments. So I'll see you in the very next video. We're going to be doing that, and we are about to be done. So apologies for the long videos, but the terminal can be a bit confusing, and I don't really want to make it any more complicated than it already is, and that's why I'm going quite slowly. In the next video, we're going to be installing MongoDB, so I'll see you there. Hi and welcome back. In this video, we're going to be installing MongoDB in the server. It's actually really simple. We have to create a file, and then that file allows us to install MongoDB using yum. So it's going to be really quick. The first thing we want to do is press sudo vi, and then we're going to modify the yum repository, which contains essentially where to download things from when we're using yum. So it's going to be etc yum.repos.d, and then we're going to add a file called mongodb org 3.2.repo. And then we're going to need to put in our password in there. And I'm going to copy, here I've got it on the side, and I'm going to give it to you guys in the lecture description as well, of course. Go into insert mode and you can paste this in. And I'm going to just delete these things there that get added automatically. And what we're adding is MongoDB org 3.2, and then the name of the repository, where we are finding the download links, the base URL, and then whether we want to do a GPG check, which, as you know, the GPG keys are used to sign things to make sure that we're downloading the correct thing. We don't want to check that, probably because MongoDB doesn't have a GPG key, and then whether this repository is enabled or not. Once we've pasted that in, press escape to leave insert mode and :WQ to save it, and then we can just do sudo yum install mongodb-org, and that's going to install it. And once that's installed, we're going to do the same thing as we did with Nginx, which is make sure that it starts in when the server reboots and things like that. Sudo check config mongod on, and now sudo service mongod start, and that starts MongoDB. And now we can do Mongo, and as you know how this all works, we have access to a Mongo shell that is running in this server. So we can now exit that. And the last thing that's remaining is setting up uwsgi, which basically just means adding a config file. We're going to do that in the very next video, so I can separate this a bit more and then explain to you guys what's going on in the uwsgi config sort of section. So I'll see you in the next video. Hi and welcome back. In this video, we're going to be adding uwsgi, not installing it, but setting it up, adding the config file to uwsgi. The first thing we have to do is make sure that the system itself knows how to run uwsgi. Well, more specifically, how to run the uwsgi container that is going to be interacting with our pricing service app. So our pricing service is going to need a configuration file that will then allow uwsgi to run. So let's add that config file. Sudo vi etc init uwsgi pricing, I can't spell, pricing service.conf. And you know how this all works. We're going to run the vi command using sudo, and the file that we're going to be modifying is /etc/init /uwsgi underscore pricing underscore service.conf. And if that file doesn't exist, then vi is going to create it, and indeed it says new file. Okay, so then go into insert mode by pressing I, and then we can do a bunch of things here. The first thing we want to do is set a description, which is going to describe what this is, and that's just for logging purposes. So description, uwsgi pricing service, and now we're going to set a couple of things, which are the run levels. And I wouldn't recommend that you worry about what this means. Start on run level 2345, and stop on run level 06. And that basically just tells it when to start and when to stop, and how to do that. Respawn. More importantly are these two things here. And these are going to be environment variables that are going to be set when uwsgi runs. More specifically, when we run this uwsgi config file. uwsgi underscore alive. This is the uwsgi executable file, which we have installed in our virtual environment for our app. And this is going to be, remember to not leave spaces beside the equal signs. var www html pricing service vem bin uwsgi. This is where we've installed uwsgi. And the other environment variable is log2 underscore alive. So where we're going to be logging to when we go live with this uwsgi program. And that is the log file we created earlier. So HTML pricing, oh, there's too many there. HTML pricing service log, and we are going to be logging to emperor.log. uwsgi works in reasonably complicated ways. There is a main emperor that controls a number of vassals, and the vassals are the threads that are running your app, essentially. You can think of them like that. So what this log file is going to contain is logs related to the emperor, the thing that controls the threads, and not related to the threads themselves. So this emperor.log file is not going to contain any output from our app. It's only related to the way that uwsgi runs. And finally, we are going to execute our app. So execute uwsgi, which is uwsgi alive. Notice the $sign in front tells us this is a reference to the variable defined above, the environment variable. Master emperor var www html pricing service /uwsgi.ini die on term uid Jose group id Jose log2 alive. Let me explain what all this is. we're going to be executing the UWSGI executable, which is this program that we defined up here, with the following flags: master and emperor. There's going to be a master thread, and there's going to be this emperor thing that I talked about earlier. And it's going to be running using the config file defined here, which we're going to look at in just a moment. And it's going to die if bad things happen, essentially. Don't worry too much about that. But essentially it's going to be shutting down gracefully, and then the user ID that is going to be running UWSGI is the current user. Remember to put your username here and not mine. The group ID of the user, sorry about that, is also going to be mine, and then where it's going to be logging to, which is this log file up here. Remember the $signs there tell us that these are environment variables that have been defined previously, which is directly above. Once that's done, press escape and :WQ to save and quit. And now we are ready to run this. However, the first thing we want to do is verify that uwsgi.ini exists, which it doesn't. So we're going to have to create it. Let's create uwsgi.ini. And the only things we have to put here are a couple of things. Press I to go into insert mode, and then uwsgi between closing brackets. This is a section which tells UWSGI that the configuration related to UWSGI is directly below it. And we're going to define the base application, the base folder for our app, which is var www html pricing-service. Which Python module is the app itself, the Flask app? And as we know, the Flask app is inside the src folder and inside the app module. And the module itself is this app module there. Okay. Then the home for the virtual environment packages is going to be base/venv virtual environment, and the Python path, i.e., where the Python essentially where Python should look for the modules to run, that's the Python path, is also going to be base. The socket file location, which UWSGI is going to be creating, has to be the same as we defined in the nginx config file, and that is var www html pricing-service-socket.sock. And the permissions to the socket have to be 777. So you do that with chmod socket 777. How many processes we're going to be running the app with, and this has to be the same as the nginx worker processes that we defined in an earlier video, which was 8, and threads 8 as well. Finally, harakiri sets to 15, and what this does is it kills the thread whenever it gets stalled for 15 seconds. So if your app goes too slowly, the threads will kill themselves so that they don't stop working. Because if all threads stop working, eventually your app will just do nothing. So you want them to terminate if they get stopped for 15 seconds or more. Finally, the callable application is going to be app, and that is essentially the name of the variable that lives inside src.app that contains the Flask application. And finally, where we are logging Flask-related output is going to be var html www html pricing-service-log-n.log, and this n is just the name of the UWSGI process that's running. I realize that's quite quick, but it's not that important. You need all these things for your app to run. It's good if you understand them, but just know that these are required for your app to run. So let's press escape and then :WQ to save that. And now we're going to move on to the next video where we are going to be running the app and seeing that everything works. So I'll see you there. Hi and welcome back. In this video, we're going to be running the app and verifying that it works. The first thing we have to do is make sure that nginx is running. So sudo service nginx start. and then we have to put in the password naturally, and that's Nginx starting. And now remember that whenever the server reboots or things like that, it will start automatically for you. The next thing we want to do is go into Safari and access the IP address and see what happens. So let's do just that. Here we're going to go into the IP address 82.196.45, 82.196.45, and we get an Nginx error. Now, we know that Nginx is running, and therefore we get an Nginx error, which means that Nginx is running, and that is working. Something that isn't running, however, is the UWSGI program. And we can tell that that's not running because if we run ls, there is no socket file in here. Remember, the socket file is what communicates with Nginx. So we want to do sudo start UWSGI pricing service. This is the same as the config file that we created above. Oh, that disappeared right before I pressed enter. Sudo start UWSGI pricing service. And that's now running. And there we go. Now that's working. And that's it. So congratulations, really. Now you've got a thing that is working. You can sign up as your name at youremail.com because that's the admin that we've got. Not now, not now. And now we can have the stores and we can create stores and everything else. There is a possibility that it won't work. And if it doesn't work, what you'll need to do is do sudo set enforce 0. And what that does is it disables some security tools. And it's not something I would recommend lightly. So try not to do that if you don't need. But apart from that, that's it working. And as you can see, you've got your thing deployed, and there is a lot of things that went into deploying this. And now you know really how complicated it is for some of these companies out there to manage their deployments. This is a single server running with a simple Python app and a MongoDB running in the same server as it. Normally, MongoDB would be running on a different server, probably over many servers. The Python app would be running across many servers. It would be load balanced so that if one server goes down, then the entire app doesn't stop working. And there's a lot of things that could go wrong. And there's a lot of things to be deployed and a lot of things to take care of. So just remember that when you see a website and you think, well, this is not that great. There's still a lot of work going into making things that work. With that said, let's move on to the next video. And I just want to say congratulations for following this far and being able to deploy. And now you know how to deploy, and whenever you create your own apps, it's going to be just so much easier for you. With that said, I'll see you in the next video. Hi and welcome back. In this video, we're going to be running our alert updater so that we get emails every 15 minutes when the price of the items goes down. We're going to do that using the cron tab, but first we need to know exactly what program we're going to be running. As you know, inside the pricing service, we've got the src folder that contains the source code, and inside of that, we've got the alertupdater.py. We want to run that Python file. Remember, we want to run all these Python files that are in our project using the virtual environment's Python version. So we do that by using vemb bin python and then src alert updater. However, this is not going to work because it says no module named src. What it's doing is it's saying, I'm running alert updater, and when I am in alert updater, there is no folder src beside it. See how alert updater in here doesn't have an src folder beside it. The src folder is the parent folder. So what we have to do is say the Python path, the root path of our application is this pricing service folder here. So the way we do that is, remember the pwd, I'm not sure if we looked at it actually, pwd tells you, never mind, the current directory, the present working directory. So what we want to do is export Python path to be equal to pwd between backticks, and that's important. And now what that does is echo Python path tells us that the Python path is the current path. So now if we run this again, it runs. It doesn't output anything, but it's running. Remember that in order to run this, you're going to need your mailgun details inside src modules alerts constants.py. You're going to need to modify that and put in your mailgun details. So our program has to do two things. Export the Python path to be this path here, and then it has to run the app. So let's write a small script that does that. By run updater, run alerts updater.sh. And what this is going to do is going to say export Python path, then path equals to var www HTML pricing service, and then it's going to say var www HTML pricing dash service venv bin python var www HTML pricing dash service dash src alert updater.py. So it's going to run the Python executable with the alert updater file after exporting the Python path, which means it's going to all run. So :wq to exit, and I'm going to do ls-l, and that's going to give us the long format of the list structure, and we've got run alert updater.sh. But notice, and now we're getting into a bit more complicated stuff, the alert updater has no X in there. The X stands for executable, and because it doesn't have X, it means that it is not executable, which means we cannot run the alert updater. So what we do is chmod ugo plus X run alert updater, and now it has the X's there. And what that does is just adds the executable property to it. If we now do run alert updater, then it runs that out. But it doesn't output anything, and because our thing doesn't. What we can do now is go to sudo vi etc cron tab, and we can put in here the details of what we want to run. Example of job definition. The first asterisk is the minute, then is the hour, then the day of the month, then the month, and then the day of the week. So what we want to do is say asterisk divided by 15. That means run every 15 minutes. Asterisk, 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 asterisk. Jose var www HTML pricing dash service run alert underscores alert updater.sh. And what that's going to do is it's going to run that program with that username every 15 minutes, every hour of the day, every day of the month, every month of the year, and every day of the week. And that's it. Now we're ready, and within 15 minutes, if the price goes down, you should be getting emails reflecting the price change. And that's how you set up a cron job. And now you're ready, essentially, to... Let me verify that that was correct. Run alert updater.sh. Yeah, okay. Just wanted to make sure. Now you're ready to deploy your app, share it with your friends, get them running it and trying it out. Make sure that this is working. Try to add an item that with a lower price limit, so to make sure that the emails do work and then the cron job does do what it's supposed to. And that's it, really. So this is the end of this section, and good job getting this far. There's not much else for me to say. And well, I'll just leave it there, and I'll be seeing you in the next section when it does come. So I'll see you there.